Hi everybody, today we're going to take a look at 20F, which is variance and standard deviation. Now variance is a sample of n data values, so you take s squared n is going to equal sigma notation from I equals 1 to n of x of I minus x bar squared. Now x of I is a particular value and x bar is the mean. You square that and divide by n. Now it's going to measure how far a set of data of random numbers are spread out from their mean. The variance is the square of the standard deviation. Now down here, you will see we have the standard deviation. So it's the same thing except for you take the square root of the variance. So standard deviation squared is the square root of the variance is the standard deviation. Now you divide by n to indicate how far an average the data is from the mean. That's why you're dividing by it. A measure that is used to quantify the amount of variance or dispersion of a set of data values. The lower the standard deviation indicates the data points tend to be close to the mean, while high number standard deviation indicates the data points are spread out more. There's a wider range of values. Now what's important is this. We are going to use x bar for the mean and this symbol here for the standard deviation. If you take a statistics course, you will learn formulas for sample standard deviation, which is S of n, and for population standard deviation, which again is a symbol. Now here's an example. A library surveys 20 borrowers each day from Monday through Friday and records the number who are not satisfied with the range of reading material. The results are following: 3, 7, 6, 8, 11. The following year, the library received a grant that enables the purchase of a large number of books. Their survey is repeated, and here are your results: 2, 3, 4, 5, and 6. Now what you're going to do is survey 1, we are going to take 3. Well, first of all, let's back up. Let's go ahead and figure out what the mean is. If I add up all these numbers together, what I get is 35. I take 35 and I divide it by 5, because there's 5 entries, and that equals 7. Now that is my mean. That's x bar. So up here, I take the number x minus 7. That equals 4, and I square the 4, and I get 16. Now I take 7 minus 7 is 0. 0 squared is 0. 6 minus 7 is negative 1, and negative 1 squared is 1. 8 minus 7 is 1. 1 squared is 1. 11 minus 7 equals 4. You square that, and you get 16. Now what we can do is go ahead and add all these up. Now when I add these up, what you get is 34. Now to find the variance, I take 34 divided by 5, and that equals 6.8. That's my variance. Now to find the standard deviation, I'm going to take that number and take the square root of it. And the square root of 34, 6.8 is 2.608. Now I'm going to do the same thing over here. I add these numbers up. This is survey 2. I add these up. Add them up and you get 10 and then 20. 20 divided by 5 equals 5. Keep in mind that's my x bar. I take 2 minus 5, or 2 minus 4. This is a 4, not 5, sorry. That equals 2, or negative 2. Square that and you get 4. 3 minus 4 equals negative 1. That's 1. 5 minus 4 is 1. Square it, you get 1. 4 minus 4 is 0. Square it, you get 0. 6 minus 4 is 2. Square it, you get 4. Add these up, and we get 10. Now to calculate the variance, I take 10 divided by 5 is 2. Now I take the square root of that, square root of 2, and that is 1.414. So what you notice is that after they added reading material to the library, the standard deviation is smaller after they added new material. Now here's a couple more examples. The height centimeters of 7 junior football players are 179, 164, 159, 171, 168, and 174. What we can do is we can put that in our calculator. And we're going to go down to add list in a spreadsheet. Just like before, I'm going to call this A. Now I'm going to enter my data values. They are 179, 164, 159, 171, 168, 174. Okay, what did I miss? 174, 168, 170. Oh, let's put another 168 in there. Okay. I'm going to come up here and I'm going to go to menu. I want to do statistics, stat calculations, 1 var. Yep, 1 var, so I hit enter. This needs to be an A. Come down to OK. Hit enter. And what I find is that my mean is 169. And if you come down a little bit further, this is my standard deviation that we're using. And remember, this is a population that's going to use. Next year, if you take statistics, you'll talk more about the sample standard deviation. So I'm going to have 6.047 or 6.05. Now, what do you suppose would happen if you added 5 centimeters to every height, or everybody's height, to the mean and the new standard deviation? Well, what we can do, we'll come over here and we'll do that. I'm just going to put an E right here. I'm going to add 5 to all those heights. So I have 184, 169, 164, 176, 173, 173, and finally I would have 179. Now I'm going to go through the same process. I'm going to go to menu, statistics or stats, stat calculation, 1 var. Hit enter, and then up here I need an E, because that's what I labeled it. Come down to OK, hit enter. Now my new mean is 174. And my standard deviation stayed the same at 6.05. So what happens when you add or subtract data values, constant data values to all your entry points, the mean's going to go up or down by that, but the standard deviation would remain the same. So X bar, or mean, went up 5, and the standard deviation stayed the same. Now, random sample is taken with the hope that it will reflect the characteristics of the population. That's what we hope happens. To distinguish between a sample and a whole population, we use different notation for the mean, variance, and standard deviation. So for the sample, it's X bar, population, it's a mu, we call it mu. Variance is S sub n squared, population is standard deviation squared. Standard deviation is just S sub n, and then with the population, it's just that little circle with a hat on it. When a sample size n is used to draw inference about population, the mean x bar of the sample is an unbiased estimation of mu. SMN is estimate of the standard deviation, which is, again, your standard deviation. A random sample of 48 sheep was taken from a flock of 2,000 sheep. The sample mean of their weights is 48.6 kilograms with a variance of 17.5. Now find the standard deviation of the sample, estimate the standard deviation of population from which the sample is taken. Now remember, on your calculator, S sub n is your sample. And on your calculator, this is for the population. Now, if we want to take a look at the standard deviation, what I need to do is I'm going to take the square root of 17.5 because that's my variance, 17.5. So the standard deviation based on that is going to be 4.18. So you take the square root of your variance, gives you the standard deviation. Now find an unbiased estimate. Now that we're going to draw from up here. The unbiased estimate in this case is going to be 48.6 kgs or kilograms. All right. Hopefully that helps. We'll be back soon.